Matter and its classification. Matter can be broadly divided into two major groups, pure and impure. In chemistry, the term purity acquires quite a different meaning from what we understand it to be in our day-to-day life. Normally, when we refer to pure water, pure milk, etc., what is implied is that water, milk, etc. are free from harmful substances such as bacteria, fungi, viruses, etc., or are not adulterated. Matter is classified as pure substance and mixture. On the basis of chemical composition, pure substance is further classified as element and compounds. Element is further classified as metal, non-metal and metalloid. Mixture is further classified as homogeneous and heterogeneous. Mixture. Mixtures can be homogeneous or heterogeneous. Let us explain with the help of activity. Take 4 beakers containing some amount of water and label them as A, B, C and D. Add 1 spoon of copper sulfate in A and 2 spoons of copper sulfate in B. Add 1 spoon of copper sulfate and 1 spoon of potassium permanganate in C and 2 spoon of copper sulfate and 2 spoon of potassium permanganate in D. Now observe all the beakers. We will observe that the beaker A and B have obtained a mixture with uniform composition through it, and also the intensity of color of the solutions is different. Such a mixture is called homogeneous mixture. This shows that a homogeneous mixture can have a variable composition. In C and D also, we obtain mixtures which contain physically distinct parts and are non-uniform. Compositions of such mixtures are called heterogeneous mixtures. From this activity we can say that the homogeneous mixtures have uniform distribution through them and have no distant boundary, while heterogeneous mixtures have distant boundary and the distribution of composition is non-uniform. Properties of solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer in diameter, so they cannot be seen by the naked eye. Because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of the light is not visible in a solution. The solute particles cannot be separated from the mixture by process of filtration. The solute particles do not settle down when left undisturbed. That is, a solution is stable. Solution. A solution is a homogeneous mixture of 2 or more substances. The lemonade, sherbet, Coke, Pepsi, etc. are all examples of solution. A solution is generally made up of 2 components as solute and solvent. Let us explain with help of an activity. Take some amount of water in a beaker and add some salt in it. Stir the solution and observe. We observe that the salt dissolves in it. Thus we conclude that a solution has a solvent and a solute as its components. The component of the solution that dissolves the other component in it, usually the component present in larger amount, is called the solvent. The component of the solution that is dissolved in the solvent, usually present in lesser quantity, is called the solute. Here the salt is solute. Now add some more salt in it. What do you observe? We observe that no more solute dissolves in it. Thus, the solution is called saturated solution. A saturated solution is defined as a solution that has dissolved as much as solute as it is capable of dissolving at any particular temperature. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. The amount of the solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. Suspension and colloidal solution. A solution is classified on the basis of particle size such as true solution, suspension and colloidal solution. Let us explain with the help of activity. Take 3 beakers and label them as A, B and C. Now add 1 spatula full of copper sulfate to beaker A, chalk powder to beaker B and few drops of milk to beaker C. Now add some amount of water and stir properly using a glass rod. Observe all the beakers. You will observe that beaker A has no distinct boundary and uniform distribution of particles through them. The size of the particles of a solution is too small to be individually seen by naked eyes. Thus the solution is called true solution and the size of particles is less than 1 nanometer. In beaker B, the size of particles of a solution is too large that we can see them by naked eyes. It is heterogeneous in nature. Thus the solution is called suspension solution. Size of the particles is more than 100 nanometers. In beaker C, you observe that the size of particles is too small to be individually seen by naked eyes. So the size of particles range from 1 to 100 nanometers and the nature of the solution is heterogeneous. Thus the solution is called colloidal solution. Leave the mixtures undisturbed for a few minutes and observe. You will observe that in beaker B, particles settle down at the bottom of the beaker, but in the rest of the beakers that do not happen. This solution is easily filtered by an ordinary paper, but the colloidal solution is filtered by centrifugation methods. The true solution particles pass through the ordinary paper. The colloidal solution shows the Brownian movement, that is zigzag and irregular motion exhibited by minute particles, while the suspension solution and true solution does not. Now direct a light from a torch through the beaker containing the mixture and observe from the front. Is the path of the beam of light is visible? Yes. In beaker C, it shows a visible path. This phenomenon is called the Tyndall effect, while the rest of the beakers do not affect the beam of light. From this activity we learnt some properties of true solution, suspension solution and colloidal solution. Let us summarize the differences between the colloidal solution and suspension solution. Separation of ink from dye. Let us explain with help of activity. Fill half a beaker with water. Put a watch glass on the mouth of the beaker. Now put few drops of ink on the watch glass. Now start heating the beaker. We do not want to heat the ink directly. You will see that evaporation is taking place from the watch glass. Continue heating as the evaporation goes on and stop heating when you do not see any further change on the watch glass. We find that the ink is separated out from a mixture of dye in water. Thus we can separate the volatile component or solvent from its non-volatile solute by the method of evaporation. Separation of cream from milk. Take some milk in a centrifuge tube. Centrifuge it by using the centrifuging machine for 2 minutes. What will you observe after centrifuging? We will find that the cream is separated out from milk. Upper part in the centrifuge tube is cream and the lower portion in centrifuge tube is milk. It is used in diagnostic laboratories for blood and urine tests and in the dairies and homes to separate butter from cream. It is also used in washing machines to squeeze out water from wet clothes. Separate a mixture of 2 immiscible liquids. Let us try to separate oil from water using a separating funnel. Pour the mixture of oil and water in a separating funnel and shake it vigorously. Let it stand undisturbed for some time so that the separate layers of oil and water are formed. Close the knob of the separating funnel as the oil reaches the nozzle. Now remove the oil from the separating funnel. Application: to separate a mixture of oil and water. In the extraction of iron from its ore, the lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. The principle is that immiscible liquids separate out in layers depending on their densities. Sublimation: the sublimation process is used to separate sublimable volatile component from a non-sublimable impurity. Let us explain with the help of activity. Take a mixture of ammonium chloride and salts in a china dish. Place a cotton plug on an inverted funnel and keep this inverted funnel over the china dish. Heat the content over the Bunsen funnel and observe carefully. We observe that the vapors of ammonium chloride is formed and deposited on the side of funnel because ammonium chloride is a sublime substance. Salts are collected in the china dish. Thus we conclude that to separate such mixtures that contain a sublime volatile component from a non-sublimable impurity, the sublimation process is used. Some examples of solids which are sublime are ammonium chloride, camphor, naphthalene and anthracene. Chromatography: this process of separation of color components from a mixture is known as chromatography. Chroma in Greek means color. It is the technique used to separate those solutes that dissolve in the same solvent. Let us explain with the help of activity. Take a thin strip of chromatography paper. Draw a line on it using a pencil approximately 3 cm above the lower edge. Now put a small drop of ink, water soluble, that is from a sketch pen or a fountain pen, at the center of the line. Let it dry. Put the filter paper into the jar containing water so that the drop of ink on the paper is just above the water level, and leave it undisturbed. Watch carefully as the water rises up on the filter paper. Record your observations. We observe that the water rises on the filter paper. It takes along with it the dye particles. The colored component that is more soluble in water rises faster, and in this way the colors get separated. This method is used in colors in a dye pigments from natural colors and drugs from blood. Separate a mixture of two miscible liquids. Let us try to separate acetone and water from their mixture. Take the mixture in a distillation flask. Fit it with a thermometer. Arrange the apparatus as shown here. Heat the mixture slowly, keeping a close watch at the thermometer. And observe. We will observe that the acetone vaporizes at 56 to 60 degrees Celsius, condenses in the condenser and is collected in beaker in the form of droplets. Water is left behind in the distillation flask because the boiling point of water is 100 degrees Celsius. Thus we conclude that we can separate a mixture of two or more miscible liquids for which there is a difference in the boiling points. Fractional distillation. Fractional distillation is used to separate the two or more immiscible liquids in the mixture and having a temperature difference of 25 Kelvin. Take a mixture of alcohol and water in a flask as shown here. Heat the mixture content and observe. We will observe that the alcohol starts boiling at 80 degrees Celsius. The vapors come out from the boiling mixture and enter the fractionating column. Cool these vapors in the condenser and collect in the collector container, and water is left behind in the distillation flask because it is least volatile than alcohols. Separation of gaseous from the air. Air is a homogeneous mixture and can be separated into its components such as nitrogen, oxygen, argon by fractional distillation. The process can be divided into various stages. The air is filtered to remove any dust. The air is then compressed to 200 atmospheres. On compression, the air gets hotter. This compressed air is then suddenly allowed to expand. This causes the temperature of air to drop. The cold air is then returned to the compressor. Here it mixes with the more incoming air and helps to lower its temperature. This process of expansion and compression continues till the temperature of the air falls to -200 degrees Celsius. By this time, most of the all gases in the air have been liquefied, except neon and helium. The liquid air is pale blue in color due to the presence of liquid oxygen. It is passed through the fractionating column, where it is slowly heated. The first gas to boil off is nitrogen at -196 degrees Celsius. When all the nitrogen has been converted to gas, the temperature begins to rise again. Argon boils at -186 degrees Celsius. Oxygen boils at -183 degrees Celsius. Each gas is collected and stored separately in cylinders under pressure. Crystallization. Crystallization is a process that separates a pure solid in the form of its crystals from a solution. Crystallization technique is better than simple evaporation. Let us explain with the help of activity. Take some approximately 5 grams of impure sample of copper sulfate in a beaker. Dissolve it in the minimum amount of water. Take out a filter paper and fold it from the center. Again fold it and make a cone. Filter the impurities out. Evaporate the water from the copper sulfate solution so as to get a saturated solution. Now cover the solution with the filter paper and leave it undisturbed at room temperature to cool slowly for a day. You will obtain the crystals of copper sulfate in the beaker. This process is called crystallization. This process is used in the purification of salt that we get from seawater and separation of crystals of alum or fitcurry from impure samples.
Chemical changes. Let us understand the chemical change with the help of an activity. Dissolve a full teaspoon copper sulfate in a half cup of water in a beaker. Add a few drops of dilute sulfuric acid to the solution. A blue-colored solution is formed. Drop a shaving blade into the remaining solution. Wait for half an hour and then observe the color of the solution. The changes that you notice are due to a reaction between copper sulfate and iron. The change of color in the solution from blue to green is due to the formation of iron sulfate, a new substance. The brown deposit on the iron nail is copper, another new substance. We can write the reaction as copper sulfate solution blue plus iron gives iron sulfate solution green plus copper brown deposit. A change in which one or more new substances are formed is called a chemical change. A chemical change is also called a chemical reaction. Physical changes. By using a piece of gold, a goldsmith can make a gold chain and later alter it to make gold ornaments. All of them consist of the same substance, namely gold. This is an example of a physical change. A more common everyday example is water. Take water in ice tray and keep this tray in freezer for an hour. Take out the tray from the freezer. Can you find any change in the water? Yes, water converts into ice cubes. Thus, water changes liquid state to solid state. Heat up the water on the flame and observe. The water changes into water vapor. From this activity we conclude that in all the three forms the chemical composition of water is not altered. Thus it is a physical change.
Element and compounds. An element can be defined as a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Elements can be normally divided into metals, non-metals and metalloids. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. Let us explain with help of activity. Take 5 grams of iron fillings and 3 grams of sulfur in different containers. Mix and crush the iron fillings and sulfur powder. Now check for the magnetism in the material obtained. Bring a magnet near the material and check if the material is attracted towards the magnet. You will observe that the iron fillings get attracted by magnet, while the sulfur does not get attracted. Thus both are elements. Now heat this mixture strongly till red hot. Remove the flame and let the mixture cool. Check again for the magnetism in the material obtained. Bring a magnet near the material and check if the material is attracted towards the magnet. You will observe that the mixture does not get attracted by them. Add carbon disulfide to one part of the material obtained and dilute sulfuric acid to the other part of the mixture. Stir well and filter. We can also observe that the texture and the color of the compound are the same throughout. We conclude that the properties of the mixture are the same as that of its constituents. On heating the two elements strongly, we get a compound which has totally different properties compared to the combining elements.